Today, we're basically becoming geological detectives. Our mission? To crack a case that's literally billions of years old, by learning to read a history that isn't written in any book, but in the very bones of the Earth itself.
Okay, so get this. The Earth is about 4.5 billion years old. All of human history, everything we've ever written down, is just a tiny, tiny fraction of that. So how on earth do we know what happened before us? I mean, how do you read a history that has no words? Well, it turns out the planet wrote its own autobiography.
And that's where the secret is. It's in the Earth's own diary. A diary it's been keeping for eons, not with ink and paper, but with something way more permanent: rock.
Just think about it like this. The Earth is an author, constantly writing its own story. Every big event, every new era, every climate shift, it all gets recorded as a new layer of sediment that, over time, hardens into rock. It's page by page, layer by layer, building the story from the ancient past right up to today.
But, okay, how do you actually read these rock pages? It's not like they have an index. Well, geologists have figured out a set of basic rules, kind of like a grammar for reading stone. And we're going to start with the most important rule of all. It's called the law of superposition. And honestly, it's so simple, it's beautiful. Think about a laundry basket. The shirt you threw in this morning is right there on top. Last week's clothes, they're buried way down at the bottom. Rock layers work the exact same way. The oldest stuff is at the bottom, the youngest is at the top. This is our first and most crucial clue.
And this shows you perfectly how it all goes down. It might start on an ancient seafloor, with sand and silt just settling, layer after layer. As creatures live and die, their shells and bones get buried in that sediment. Then, over millions and millions of years, the crushing weight of new layers on top squishes it all together, cementing it into a solid layer of rock. And just like that, a new page in the diary is written.
Of course, the Earth's diary isn't always perfectly neat. Sometimes huge events happen that mess up the pages. An earthquake can crack the layers, creating what we call a fault. Hot magma can push its way up from deep inside the Earth. But even these disruptions are clues. This is where the rule of cross-cutting relationships comes in. It just means that whatever did the cutting, the earthquake fault, the magma, had to have happened after the layers it's cutting through were already there. It's like spilling coffee on a stack of newspapers. The spill had to happen after the papers were already stacked up.
Now here's where it gets really interesting. These rock pages, they aren't blank. They have the actual words of Earth's story written on them. Fossils.
We're talking about the preserved remains or traces of ancient life. You know, a shell, a bone, even a footprint. Every single fossil is like a photograph, a snapshot of life at the exact moment that page of the diary was being written. These are the characters in our epic story. And man, fossils tell us so much. They show us how life has changed and evolved. They give us clues about what the world used to be like. I mean, if you find a fish fossil in the desert, you know for sure there used to be water there. They are direct records of life's history, and you almost always find them tucked away in those layers of sedimentary rock.
So while most fossils tell you a local story, there are a few really special ones that act like a master key for the entire planet. They're called index fossils, and they are a geologist's absolute favorite shortcut.
But how does that even work? How can one single type of fossil act like a universal timestamp? How can finding the exact same shell in, say, Colorado and in China prove that the rocks they were found in are the same age?
Well, it all comes down to 3 really strict rules. First, the creature had to have lived pretty much all over the world, so you can find its fossils everywhere. Second, it had to have existed for a very short, specific slice of geologic time. If it was around for hundreds of millions of years, it's not a very good time marker, right? And third, it has to be super easy to recognize, no confusion.
So think about it this way. A regular fossil is like a story in a local town newspaper. It's interesting, but it's only about that one place. An index fossil, that's a global headline. When you find one, you've pinpointed a specific moment in Earth's history, no matter where you are. It's the thing that connects all those local stories into one massive single history.
All right, time for a pop quiz. Let's put you to the test. Here are 2 columns of rock layers from completely different continents. They look different, they have different kinds of rock, but can you tell me which layers were formed at the exact same time?
And there it is. The index fossil is the link. See that little coiled shell? Because we know that creature only lived during a very specific window of time, finding it in both columns is definitive proof. Layer B on the left is the exact same age as layer G on the right. We just connected rock layers across thousands of miles. That's the power of an index fossil. Okay, so now we have the rules, we have the pages, we know about the disruptions, and we have the words inside. Let's see how the geological detectives use all this stuff to reconstruct entire ancient worlds.
By combining everything, superposition, cross-cutting relationships, and index fossils, geologists can build this incredibly detailed sequence of events. Now, they might not know if something happened exactly 80 million years ago or 82 million years ago just from this, but they know for sure that the dinosaurs died out before the rise of mammals. It's all about the order of the story. We call it a relative timeline.
And from that, a clear story just emerges. First, an ancient ocean forms, making the bottommost layer of rock. Then, a unique creature, our index fossil A, evolves and spreads across the world. After it dies out, a giant volcanic eruption lays down a brand new layer of ash. Above that, new life appears, our index fossil B, before, finally, a major extinction event wipes the slate clean, ending that whole chapter of Earth's history. We can read all of that just by looking at the rocks. It's amazing.
And this isn't just a clever theory. As one source puts it, thousands of layers of sedimentary rock confirm the long history of the changing surface of the Earth. The evidence is overwhelming. It's written in every canyon wall and roadside cut all over the planet.
Which kind of leaves us with one last big thought. Millions of years from now, our entire civilization will just be another thin layer in the rock. So, what story will our fossils, our cities, our plastics, our bones, what will they tell the geologists of the future? What's going to be written on our page of Earth's diary?